The runtime in MVC3 also gives us a chance to resolve dependencies for view components. This includes view engines and the views themselves. View engines are components implementing the iViewEngine interface, and there are two available in an MVC application by default, the WebForms view engine and the Razor view engine. You can add additional view engines into the runtime using your custom dependency resolver, because again, the MVC runtime is going to check the dependency resolver to see if there are any view engines available. Views themselves are also passed through the dependency resolver. We saw this when we were stepping through code with the debugger. This means we have the opportunity to inject dependencies into a view. There is a twist, however. Because of the technique used to generate and compile classes from a view template, we cannot just provide a constructor with parameters and expect to have constructor injection work, like we did with our controllers. However, most IOC containers can perform what we call property injection. That is, we can provide a needed dependency by setting a property. In this code snippet, an object expects us to provide an iMessenger. One approach to property injection that most containers understand is to decorate a property that requires injection with some sort of attribute. In Ninject, this can be done with the inject attribute that you see here. When Ninject sees that, it knows that this is a property that it needs to populate with an iMessenger. You'll need to define this property on a base class and have your Razor or WebForms views derived from this base class. You can specify the base class in a Razor view by using the inherit attribute, and you could also do this by editing the web.config file in the views folder to specify a base class for all Razor views in the application. Let me give you one word of caution before we look at a demonstration. Be careful not to inject services into your view that will allow you to violate the MVC principles. A view is responsible for rendering the model. It should not be logging information, talking to the database, and it probably shouldn't be sending messages either. This is something that we should have done during execution of the controller action, so keep in mind, this demonstration is only showing you what is technically possible. Inside of Visual Studio, here's the messaging web view page of T that I expect to be the base class for some of my Razor views. It has a messenger property, and we expect this property to be set by Ninject because I have the inject attribute here. That's an attribute that only Ninject understands. Depending on what IOC container you might be using for your dependency resolver, you might have to apply a different attribute there. The index view is one such view that I expect to use that messenger. It inherits from messaging web view page of T, and it uses messenger.sendMessage here. I'll put a breakpoint so we can actually see when that line of code is hit and that there's a messenger available. I am going to make one change here just to demonstrate a technique, and that is the inherit directive that I have here will work and correctly set the base class for me, but there's another way that I can do this. I'll remove the inherits directive and instead open up the web.config file in the views folder, and I'll set that base page type here. And now what I've done is I've set that base type for all of the Razor views inside of my application. I no longer need the inherits directive here. Let me also remind you that over here inside of global ASAX, we have told Ninject that when something needs an iMessenger to use an instance of the SMS Messenger class. And before we start things running, I'm going to set a breakpoint here inside of get services. Previously, we had a breakpoint inside of get service. The MVC runtime calls get service when it expects to get a single service back. It will do that for things like the controller factory. There's only going to be one controller factory for the entire application. But other services, we can have one or more available. One example is the view engines. By default, MVC is already using two, WebForms and Razor. We can add 2 or 3 additional view engines inside of our kernel and have all of those view engines in play. Let me strike the F5 key and see how the application behaves. We'll see a call here to get services, and the MVC runtime is looking for filter providers. We'll talk about them in just a minute. I'll strike F5 again. This time the MVC runtime is looking for a collection of view engines. So this demonstration is just to point out that yes, the MVC runtime does use your dependency resolver for nearly everything, including to find out the view engines. And that means that you can simply configure your view engines into your kernel just as you're doing with all your other components, and the MVC runtime will find them. Contrast that with the approach that we had before there was a dependency resolver in MVC 1 and 2. In those cases, you had to use a completely different API to register a view engine. In that case, it was the view engine.engines collection, and that's still supported in MVC 3 for backward compatibility, but this approach is going to be much nicer. You can centralize all of your dependency configuration. Let's continue on with an F5, and you can see that we are inside of our view and that we actually have an instance of SMS Messenger for our messenger property, and that is because, even though I didn't have the breakpoint here, the MVC runtime came through the dependency resolver when it needed to resolve that view. Our kernel figured out how to inject that SMS service into the messenger property.